In this lesson, we're talking about proving lines parallel. So last lesson, we had if you have two parallel lines, what that meant. Now we're going to go backwards. If I happen to have corresponding angles that are congruent, that's going to mean that two lines are parallel. So we call that the converse of a postulate. So it means like the backwards is true. So last time we had P implies Q, and now we're going to do the converse, we call that, where you do the opposite. Q implies P. So that's what's happening here. So what happens here is if we have corresponding things are congruent, if I could show angle 1 is congruent to angle 5, and then we could say that the line M is parallel to line N. So it's kind of working backwards. If I could show these two are the same, then it means that these are congruent. These are parallel, sorry. And it works for all the corresponding, right? So 2 and 6, those are corresponding. So 1, 3, 2, 6, 4, and 8. And 3 and 6, 7. Right, if I could show those are congruent, then that to me that those two lines are parallel, because it only works, right? These are only parallel if those are congruent, and the opposite is true, the converse is true. These are only congruent if those two things are parallel. So both ways work. It also, we could say the same thing about alternate interior. So for example, 3 and 6, right? If I can show angle 3 is congruent to angle 6, that also means that M must be parallel to N. And there's also angle 4 and angle 5. By the way, that's a parallel symbol, the parallel lines. I don't do a very good job of drawing parallel lines, but that's my parallel symbol. And then alternate exterior angle theorem. So remember, alternate, and they're on the exterior, so these guys. Right, if I could show angle 1 is congruent to angle 8, then that shows that angle M is parallel to angle N. So I tried to do a nice one that time. I also go for angle 2 with angle 7. Those are also all exterior. It's like that. Oh, and then we have same side. Almost forgot. So same thing for same side, right? If I could show that angle 4, so same side in the interior, angle 6. Right, so same side interior, they're on the same side in the interior. Remember, this one's a little different. If we could show angle 4 plus angle 6 equals 180, then we could also say that M is parallel to N. That would also work with angle 3 and angle 5. Like that. Okay. The transitive property of parallel lines theorem. So all this is saying is this. If you have two lines parallel to the same line, so like let's say this is L, M, and N, and I tell you L and M are parallel, and I tell you M and N are parallel, right? So I'm like, these two guys are parallel to each other, these two guys are parallel to each other, then it only makes sense that then they must all be parallel to each other. Then this guy must be parallel to that guy, basically. Then L must be parallel to N, right? So L is parallel to M, M is parallel to N, then it makes sense that L is also parallel to N, so they're all parallel to each other. And it kind of works the same for if they're perpendicular, right? So if I'm telling you that this line here, if I say that T is perpendicular to L, and we know that L and M are parallel, then it makes sense that T is also perpendicular to M, right? Because that means that these form a certain angle. So, well, that would also, since these are parallel, you get the exact same angle. It's like corresponding, basically. Okay, let's do a few examples. So find the value of x that makes M and N parallel. So again, it's a little different. Like these are not technically parallel, but we want to make them parallel. So we got to find the value that makes this parallel. We can pretty much do it the same way though. If I want to make these two guys parallel, then these are corresponding. That means that if they're parallel, they must be equal to each other. So 7x equals 140. And we just divide both sides by 7. And x would equal 20. So 20 makes those two guys parallel, because that means that these will be corresponding, right? In this case, these are same side. So if I want those two lines to be parallel, that means that same side must be equal to 180. Let's do the math here. Remember, add these two together first. 5x equals 180 divided by 5. So x equals 180 divided by 5. So that's 3. That's 15. So that's 30. So 36. It's okay to do long division on the side. Okay. Again, same concept. What makes these things parallel? So these will be alternate exterior congruent. Or if you hear me sometimes, I'm like, I don't remember that one as often. I would kind of do this. I'm like, okay, these are vertical angles. These are corresponding, so they must be equal. Well, if we want them to be parallel, they must be equal. Again, you can skip that if you just know alternate exterior, but I don't know that one that well. Anyway, so we solve this one. Minus 2x from both sides. You want to only get one variable. So 38 is equal to 7x plus 3 minus 3 from both sides. 35 is equal to 7x divided by 7. X would equal 5. So that's the value of x that makes those two things parallel. And the last one here, right, again, we want to make these parallel. So if these are parallel, that means that these must be alternate interior. And those have to be congruent. So it'll be 5x minus 1 is equal to x plus 99. And again, now it's this algebra. I have two x's, let's get rid of the smaller one, minus x from both sides. So we get 4x minus 1 equals 99. So let's add that 1 to both sides. 4x equals 100. Then we divide by 4. X will get you 25. That's what makes them parallel. And that's the video.